everyone. Thank you to those of you who are joining us in person in San Francisco and virtually around the world. My name is Walker Chabot, and I'm the Product Marketing Manager for Code Scanning here at GitHub.
And I'm Pavel Avgustinov, VP of Engineering, responsible for GitHub security products. I joined GitHub about 3 years ago with the acquisition of Semel, which I co-founded, and which still forms the basis of our code scanning product.
I think it would be wise to start with an introduction of SAST. For those of you who might not be familiar, SAST stands for Static Application Security Testing, sometimes also referred to as static code analysis.
Right, and the word static here is used in contrast with dynamic analysis, which would observe program execution. So when we do static analysis, we do not execute the program, but rather we reason about its source code.
So with static analysis, we can inspect code for patterns that indicate common vulnerabilities.
Exactly. And with CodeQL, the approach is that we create a database containing everything you might want to know about the source code, and then we execute analyses against it as queries. And so the semantic analysis engine that powers code scanning is just that.
Awesome. Well, what's the story behind CodeQL? You know, what was the inception of it? How did it come to be?
Oh, it's been a long time. So it came about as a spin-out from the University of Oxford, almost 15 years ago, I guess, at this point. And we started out kind of in the space of code analytics, code analysis, worked through code quality and bug findings, various other static analysis applications. There's kind of a fun story with an early customer of ours, the NASA Jet Propulsion Lab.
Wow.
I think some of them are here at GitHub Universe, actually, so give them a wave. Hey, folks. So when the Mars Curiosity rover was traveling to Mars, that's a long journey. That's like 7 months of plummeting through space. And I don't know if you remember, they had this really complex way of landing it, a parachute, a sky crane with boosters, lowering it down on a big rope. And they were testing the code while it was going through space. Right. And as one does, as a developer, they found a bug, like a crashing bug in the landing module. And so we got an angry phone call saying, hey, why didn't you help us track this down? We're like, well, sure, but none of the other tools you used did. And so we said, can you tell us what the problem was? And they described it to us. And within a couple of hours, we'd written a query in CodeQL to capture that problem and send it across. And they ran it against the code. It flagged the original problem, but it also flagged a number of other instances, another 3 instances in the same landing module and others elsewhere.
Wow.
So they were able to fix those, and we got permission to talk about the story as long as the landing was successful, which it was, fortunately. So it's been great fun working with those folks. And so from then, we kind of pivoted a little bit more to security analysis, because that's actually the space where you really benefit from having custom and customizable analysis. It's an arms race, right? You're always getting vulnerabilities coming in, and you need to find them. You need to adapt your tooling to respond to whatever has been dreamed up by, the bad guys. And so we started working with the Microsoft Security Response Center, actually, and they were great partners. From there, we branched out to every other big tech company with a security response team, and ultimately, this led to joining GitHub, which has been a really great cultural fit, right? At Semel, we always wanted to secure the software that runs the world,
right? And
that really meshes with GitHub's mission to, be the home for all developers and secure the world's software as well.
Awesome. Awesome. So it's clear a lot has changed since the inception of CodeQL. I'd like to take a moment to talk about what matters in a SaaS solution. There are 3 key considerations that we typically like to think about: completeness, accuracy, and speed. Let's first talk about completeness.
Sure, and there's a couple of aspects here. So on the one hand, and this is an advantage of static analysis in general, completeness can mean actually analyzing all the possible execution paths, the entire source code, everything about it. Again, contrast to dynamic analysis, where you have a particular execution, a particular flow of the code through the program that you're observing.
Right.
Here, we're trying to capture all possible behaviors. Completeness is also about having a good enough picture about the threat model that you're operating in. What are the APIs that matter? Where does network data come into the system? What are the sensitive points where you don't want attackers to be able to reach?
Right.
And finally, of course, it's also about just supporting all the code that we want to analyze, all the languages that people use, all the new versions of those languages, because people keep making them better and bigger. And of course, we have to keep up with all that. But yeah, it's all in good fun.
Awesome, awesome. So what about accuracy? How do we think about that?
Oh man, well, the key thing to realize is false positives are a killer, right? And that's been the problem with static analysis for a long, long time.
Right.
When you present results to the developers, they're going to look at the first three. If they're bogus, they'll never look at your tool again. So you've got one shot. And so we've really focused on having super precise analysis, high quality results that are actionable, that apply to your code. And we think this is where CodeQL shines, because it's customizable and it's easy for us to iterate on the analysis. We can easily respond to particular cases that arise. Maybe an API changes and something becomes a false positive, or we haven't considered something. We can quickly fix that and keep making the analysis better. We also try to pull the community into this, because all the analyses are open source on GitHub. Another aspect of accuracy, of course, is false negatives. How do you know that you're actually capturing a meaningful number of the vulnerabilities that are in there? And we can never give you a guarantee, right? That people will always find vulnerabilities that you haven't thought about. But we do try to track the effectiveness of our analysis against real-world vulnerabilities. So we will look at the stream of public CVEs, and we'll check how many of those our analyses flag. And often, that's one of the best ways of improving the analysis. If you see something that we expected to flag, but we didn't, well, why not? What's missing? What do we need to add? And it's led to some great improvements over the years.
Awesome, awesome. So last one, speed. This is an interesting one.
We're developers. I mean, what can I say? If it's not fast, I'm not going to use it. You're not going to use it, right? But what is fast? I think, the key criterion is it has to be fast enough to integrate in the developer workflow. And we believe a sweet spot for that is in the pull request flow. And so you can think of it as, well, as a baseline, it should be as fast or faster than the human review you get, right?
Right, you would hope so.
The humans shouldn't wait for the machines. But, of course, that's not always possible. Speed can also be about scalability. We do a lot of work with Microsoft, and Windows is probably the biggest C++ code base in the world. And analyzing that thing is always going to take many hours, right? But the key is, in that context, speed means you actually are able to scale, to not break when you look at 180 million lines of C++. You actually still give useful analysis results on that code base.
Awesome, awesome. Well, now let's talk about code scanning. So code scanning allows for CodeQL's results to integrate directly into the developer's workflows by populating right in GitHub. This means that developers are able to see vulnerabilities at the code level and with every single pull request. This allows them to easily find and fix vulnerabilities early in the development process.
Exactly, and that's our philosophy, right? Security tools should be at developers' fingertips. And code scanning, or CodeQL, you can think of as having an extra security reviewer on the team who's just going to look at every PR you submit and just flag problems that you might be introducing. And they appear just like any other pull request feedback that you might get from your teammates. Right? So you can see them on the pull request view, you can discuss them, what's going on here, is it wrong, is it right, how do I fix it, is it fixed? Of course, when you do actually fix it and you push the fix, we'll recognize that and dismiss the comment. So it's the right point to integrate security tooling. And code scanning in general actually acts as a platform for other static analysis too. We allow dozens of open source and partner engines to integrate into the developer workflow in the same way as we do with CodeQL as our in-house analysis tool.
Yeah, I mean, code scanning allows you to bring in results from other application security solutions like DAST or container scanning tools.
You could do that, absolutely.
Wow. Very cool, very cool. So looking back on the past year, what were some of the highlights of code scanning?
I mean, the team's done so much great work, it can be hard to pick favorites. There's a few that stick in mind. We ship the feature that we call developer-friendly alerts, which is the pull request integration I've been talking about, presenting it right there in the flow rather than hiding it in a separate tab. And we've seen huge benefits from that just in terms of engagement, in terms of how people react, how people, even notice the alerts.
Right.
It's easy to overlook something that's hidden away in another tab. Another one is, the CodeQL engine keeps getting better. We talked about speed.
Right.
And so before GitHub Universe, I asked the team to pull some numbers on, how we're doing against last year. The engine itself, running the same analysis, is 25% faster today.
Wow.
And this is just the start. We still have, lots of improvements that we're going to make, but that's key. And then on kind of reach of the analysis and on completeness, as we spoke about before, we are declaring general availability for Ruby at GitHub Universe this year, and we're adding support for more programming languages that matter to our users and to the open source community. So the key ones are Kotlin and Swift, which are kind of the big mobile app ecosystems. They're on the way. We expect to have betas in the next couple of months or quarters. We'll see how that goes. There's also been a whole bunch of work just making it easier for security researchers to share their work through CodeQL. So we've improved the packaging story, we've improved the tooling that they use to write queries, we've improved the way that you can model API endpoints, and there's just so many things that are going on in CodeQL. I'm super excited about this work.
Awesome, awesome. Anything else you can tell us about what's coming up? Obviously, you mentioned Kotlin and Swift, which are very, very exciting, but anything else?
There's lots. Again,
I love it.
I want to go back to the speed aspect. So the faster it is, the better. We're exploring all sorts of ways of improving reliability and speed of the analysis. Part of that is the engine. Part of that is the tools that extract data and put it in the database. Part of that is, the surrounding tooling. Can we make it incremental? When we look at a pull request, can we only do work proportional to the diff rather than to the whole commit? There's actually some talks going on here at Universe about very early stage experiments from GitHub Next about what it would take to make even more of the engine incremental in that way.
Wow.
And then another really cool thing that we're focused on is ease of use and ease of adoption.
Yes.
Right? So one thing we're hearing from customers is, hey, it can be difficult to roll it out to all of my organizations. I need to commit a YAML file for the actions workflow. I need to maybe specialize it to my particular build. And so we're really thinking about how can we make that experience better? How can we just let you, as an admin, click, yes, I want to use CodeQL code scanning, and just enable it on every repository where it makes sense. Those are kind of things I'm, again, looking forward to over the next few months.
Wow. Very, very exciting. Well, thanks again for joining us. We hope you've learned a little more about code scanning, CodeQL, and application security as a whole. We encourage you to try out code scanning on all of your repos. Thanks for joining us.
Thanks, everyone.